Hello, I'm going to demo to you deploying Driverless AI MOJO scoring pipeline into a Flink data pipeline and send it those predictions to a Kafka topic. We'll start by launching a new EC2 instance. Ubuntu 1804, T2 2x large. We'll keep that as is. We'll change this to 128. Keep that as is. We're going to add all traffic on all ports and all IPs will be able to access it. Quick review and launch. We're going to choose an existing key pair, EC2 model deployment. What I'm going to do, I am next going to open a new terminal. And I'm going to open three more terminals. We'll start with this one in the top right corner. We're going to update the bash profile. We're going to update this environment variable DAI MOJO CDF instance. Go to our new EC2. We're going to copy the public DNS, paste it here. We're going to run source on bash profile. Now we have access to that environment variable. You need to do the same for these other terminals that I have currently open that I'll be using. I'll start by SSHing into the EC2 instance in this top right terminal. Next, going to create the environment directory structure. This is where our Driverless AI MOJO scoring pipeline will be, and also the test data. Alright, so what we're going to do now is we're going to send over our mojo.zip that is located in the DAI model deployment directory. We'll use scp-i mojo.zip followed by Ubuntu and the directory we want to send it to, which is DAI model deployment. Okay, and then while that's happening, what we're going to do next, in our EC2 terminal, we're going to install unzip. Okay, and we're going to then start installing Anaconda. Type yes, type enter, or click enter. Type yes, run source on bash rc. Now we've fully installed Anaconda. Our mojo.zip file's been sent over. We're going to go into DAI model deployment, run an unzip on the mojo.zip. Okay, we'll create a model deployment, Conda virtual environment, and we will go into that environment and then we'll install OpenJDK version 8. Now we'll install Maven. So what I'm going to do next is I'm going to send over the Driverless AI license file using the other terminal. It's in desktop, model deployment, common license, license.sig, and then followed by our Ubuntu instance and where we want to send it to. Alright, just need to specify the PEM key first. Now we're going to do some preparing of the data in our EC2 instance, starting with the batch data, and then we'll move to the real-time data. Each individual file has one row of data. Now what we're going to do is we're going to download Kafka, where we'll work on setting up Kafka on our EC2 instance. So to run the Kafka environment, or to run Kafka on our EC2 instance, we need to start the Zookeeper service, and we also need to start the Kafka broker. So in this terminal, I'll start Zookeeper service. In this terminal, I'm going to SSH into the EC2 again. Go into the Kafka directory, start the Kafka broker. Of course, I also need to go into the model deployment on the environment. Okay, and then I'll SSH into this one. SSHing into the EC2 instance from this terminal, and we're going to create a Kafka topic. So we will need the public DNS again. So we'll start with the Zookeeper argument, pass the public DNS of the EC2, followed by 2181. We have replication factor argument and partitions argument. So those are both set to 1, and then we have the topic argument, and that's set to DAI MOJO predictions. Of course, I am in the base environment, so I need to go into the model deployment. Alright, now what I need to do is go into Kafka folder, and then I'm just going to copy and paste this. We will create our Kafka topic, which didn't come out correctly. There's supposed to be a space there. So the topic's been created successfully. Okay, in this other terminal, what I'm going to do is I'm going to SSH back in to the EC2 again. We're going to focus on downloading and installing Apache Flink for a Flink local cluster. Keep in mind I do have the Zookeeper Connect and the Kafka broker running. So we'll start by, we're going to be using echo and tappend to add new configuration to Flink conf YAML file. What we're doing is we're adding the JVM system property for the Driverless AI license file, telling Flink where it's located so then it can execute the MOJO scoring pipeline code. And we're going to start the Flink cluster. Right, and this just is telling us we need to go into the model deployment, have access to Java. Okay, we've started our Flink cluster locally, so now we're going to access the UI. Okay, now we're ready to clone, and then, so we're going to clone the Driverless AI deployment examples repository. Now that we've cloned the AI deployment examples repository, let's clear the screen. And then let's cd to our DAI Mojo Flink data pipeline directory in the Mojo Flink project, and we're going to run maven clean install. Okay, and before we submit our Flink job, what we're going to do is we're going to read from our Kafka topic so that when we do send the data, alright, we're already in our, when we do send the data to our Kafka topic, we'll be able to see it appear in the terminal here. So I have some arguments that I'm passing to the Kafka consumer. I'm passing the topic that we want to read from, the Bootstrap server, so I just have to get, again, the EC2 public DNS, followed by the port, which is 9092, and then we're saying we want to read from the beginning. Okay, now we're ready to submit our Flink job. So I'm going to copy and paste the command in. Start there. This part of it, I need to get the public DNS again for the Bootstrap server. We have one of them, and then we have Zookeeper Connect. Followed by just the public DNS, and then the port will be different, 2181. So I'm executing Flink run, followed by the entry point path to the main class, which is real-time predict hydraulic cool condition Kafka. and then I'm specifying the path to our jar file that has that class and the helper functions, and then I'm specifying as an argument the topic that we're going to be sending the predictions to, the Bootstrap server, so the Kafka broker where that's located, and the Zookeeper connect, so where Zookeeper is located. We're going to submit this job. And what we need to do here, so we can see this error, its exception message, just shows up because Flink isn't able to read or have access to it's not able to see the Driverless AI license file. So we just have to create a temporary environment variable for that. And then let's try to submit the job again. So the other place where there can be an issue happening is also in the Flink directory, our conf directory. It could be that Flink isn't able to read the configuration that we added, so we'll just need to check it. We may need to just delete it and then add it back in. So what we'll do, start by going into the config file at the bottom here. Yeah, we'll just delete it, and then we'll manually add it back in. Starting with the comment first, followed by and we need to just remove one thing. So this is the JVM system property for Driverless AI license file. So do that, go back, stop the Flink cluster, we're going to start the Flink cluster. Reload the page. Also make sure we're looking at our Kafka topic, and we're going to submit the job again. So here we can see the job submitted successfully. We can see the predictions that have been sent to the Kafka topic. So we can see here we have cool condition 3, 20, 100. That's the key. And then on the right side of the colon, we have our prediction values 0.40, 0.21, 0.38. And what these are telling us is that from the classification, that hydraulic cool condition 3 is most likely the result. So the hydraulic cooler is most likely operating at close to total failure, and that's from looking at these probabilities or the decimals. We can see that from this 0.40 because it's the highest one. If it was 20, that would mean that the hydraulic cooler is operating at reduced efficiency. If it was 100, the hydraulic cooler was operating at full efficiency. But in fact, from looking at these probabilities, we can see that the hydraulic cooler is operating at close to total failure. Oh, and next what we want to look at is the data flow of Flink. So we're pulling in data from a custom file source, and then we have multiple functions that are being executed to one is running the Driverless AI MOJO to do real-time scoring, and then the next function is adding a key to each prediction for Kafka, and then the final function is a Flink data sync that also has the Flink KafkaProducer to push real-time scores or predictions to the Kafka topic. And so what that looks like in the code is I'll move my IDE over. So our data flow, what we can see is we have a stream execution environment. We are using Flink's parameter tool to get the arguments that we had passed in when we submitted our Flink job. We have the path to the driverless AI MOJO scoring pipeline, the path to the hydraulic system data, and they're in these particular, well, the real-time data is in this directory, and we have the direct path to the pipeline.mojo, and then we're getting the real-time data, and it's being stored into a data stream object called hydraulic. Then we're calling on predict real-time data to use the pipeline.mojo, perform predictions on the hydraulic data, and get back the predictions of now hydraulic cooling condition. And then what we're doing with this next method is we're adding the key to each prediction using the pipeline.mojo. So with the pipeline.mojo, we're able to get the output column names ahead of time. Well, in this case, we've already performed the prediction, but we could have also used the pipeline.mojo to get the column names ahead of time. But in our case, what we're doing is we're getting the output column names for the predictions, and we're adding the column names to each row right next to the prediction values, and we're separating the column names and the prediction values with a colon. And next, what we're doing is we're using Flink's parameter tool to get the topic argument, the Bootstrap servers argument, the Zookeeper connect argument, and store them into these string variables. And then we're passing some of them into the properties. So we're setting a property for Bootstrap servers. We're doing it for the group ID, the Zookeeper connect. For the parse key property, we're specifying that we do want to parse for the key. And then the key separator is the colon. So in fact, when we were looking at the data, the events that are showing up in this Kafka topic, we could see cool condition 3 to 100 is the key, and then it's separated by that colon there. And that's just some preparation before we send the data to Kafka. And then we're adding those configurations to our Flink Kafka producer, and then we're passing in the Kafka producer to Flink's add sync, where then we're pushing the stream keyed scores to the Kafka topic, and then we call on our execute Flink stream job method to execute the stream job. Feel free to dive deeper into the code. It is on a GitHub repo, and I hope you had a good time going through the deployment of driverless AI MOJO scoring pipeline in Apache Flink and sending them to the predictions to Kafka topic.